So good morning to all. Today we are going to see about a new algorithm called Advanced Encryption Standard AES. Already we saw about a earlier algorithm called the DES algorithm. Now we are going to see about an algorithm called Advanced Encryption Standard algorithm. Shortly we call it AES. So AES is a block cipher algorithm used for commercial applications. This is also a block cipher algorithm like DES. Used for commercial applications. It uses a 128-bit block size. So this algorithm uses 64 bits, but here we use the block size is 128 bit, and the key sizes vary with 3 different key sizes: 128 bit key size, 192 bit key size, and 256 bit key size. So there are 3 different key sizes, but in this algorithm the key size is 64 bit. So the AES does not use a piecewise structure. So like as piecewise microstructure is used in the DES algorithm, but the AES does not use a piecewise structure. Instead, each round consists of 4 separate functions. One is the byte substitution, the second one is permutation, third one is arithmetic operations over a finite field, next one is XOR with a key. So these 4 operations or functions is used in a round. So AES is a symmetric algorithm, like as this algorithm. It means the same key is used for both encryption and decryption. So AES is published by National Institute of Standards and Technology in 2001. So this in 1977. So after the development of the DES algorithm only, AES algorithm is published in National AES algorithm is developed in 2001. So now we are going to explain the AES algorithm by considering the block size as 128 bit and the key size as 120 bits. Some history about the AES algorithm. Actually, National Institute of Science and Technology, 1997, they called for some contest like Advanced Encryption Standard. From 1998, they received 15 submissions of new algorithms. 1999, out of 14, 5 algorithms were selected. Then October 2001, one of the algorithm is finalized. That algorithm is developed by Rindael, R-I-J-N-D-A-E-L. He is a person. His algorithm is selected as an Android encryption standard algorithm. So the designer of the advanced AES algorithm is 2 persons. So this algorithm is also known as Rindael algorithm. Dr. John Diamond and Dr. Vincent Ridgman, both belongs to the country of Belgium. They developed these 2 algorithms, AES algorithm. So the AES algorithm is also known as Rindael algorithm. It is developed by 2 persons, John Diamond and Vincent Ridgman. In this algorithm, there are 16 rounds are there, but in AES algorithm, the number of rounds varies depending on the key length. So key, for example, there are 3 different key sizes in AES algorithm. So key size is suppose 128 bit key size is used, the number of rounds is 10. If you use key size is 192, the number of rounds will be 12. If you use key size is 256, the number of rounds becomes 40. So here we assume that we are going to explain the AES algorithm with the input block size of 128 bits and the key space is 128 bits, so the number of rounds will be 10. So this is the flow diagram of AES encryption and decryption process. The figure is split into 2 halves, the left half and right half. The left half shows the encryption process and the right half shows the decryption process. So encryption, already you know what is encryption. Input is plaintext and output is ciphertext. So see the left side portion of the figure. The center portion is the key generation. So the input plaintext is given to a function called add round key. So in the add round key, the key is received from actually key size is 128 bits. So the 128 bit is divided into 100 bits. So because the 100 bit will be used in add round key process. Then after the output of add round key, it goes to a process called it goes to a round 1. So before going to round 1, the plain text is going to a process called add round key. So the round key will be added in the key used to. Each round has 4 processes. Already 4 functions. Already told them by substitution, shift rows, mix columns, then add round key. So this is round 1. Then so this same round will be repeated 10 times because the key size is 128 bit. So the first round is consists of 4 functions: by substitution, shift rows, mix columns, and round key. Likewise, all the rounds have the same 4 functions. The condition is except the last round does not have a function called mix columns. The last, see the figure in round 10, it has only 3 functions: by substitution, shift rows, add round key. Mix columns doesn't have. So each round utilizes a key. Okay, the key is generated from the main key. Hope you can understand. The plaintext is given to the simultaneous ciphertext with the help of 10 rounds. Before going to round 1, it goes to the process of add round key. Except the last round, all round has 4 functions, but in the last round there are only 3 functions except the mix columns. See the right side figure. This is the AES description. The input is ciphertext and the output is plaintext. So the ciphertext first going to the process called add round key. Then it goes to around 10 rounds. And every round has the 4 processes, but the process is all inverse of the encryption process. That is inverse shift rows, inverse byte substitution, add round key, then inverse mix column. The same from this process consists of a round. So the round is repeated 10 times, except the last round does not have mix column process, inverse mix column process. It only have inverse shift rows, inverse byte substitution, and add round key. So I think you see the diagram. Actually, plaintext is given to add round key, then goes to one round. Each round has 4 different functions. Likewise, the round is repeated. Then except the last round that has only 3 functions: byte substitution, shift rows, and round key. Does not have mix columns. Likewise, in decryption, the ciphertext is go to add round key process. Then it goes to 10 rounds. Each one has inverse shift rows, inverse byte substitution, add round key, inverse mix columns. But the last round does not have inverse mix columns. I want to one important point to the structure of this AES encryption and decryption. You see, the plaintext is given to add round key. After that goes round 1. Round 1 the first process is byte substitution. Second process shift rows. Third one is mix columns. Then add round key. This order will be followed for every round. In the last round, byte substitution use shift rows, but it doesn't use mix columns. Then directly go to add round key. We get the ciphertext. See the decryption, because the identical structure is used. What is the left side here? Add round key. The same add round key is used in the right side. Then here shift rows. So the same operation is used, but in this decryption, so use inverse shift rows instead of shift rows. Here byte substitution, so there is equivalent operation is used. Instead of byte substitution, use inverse byte substitution. Then add round the key. Then inverse mix column. That is the function is identical. So add round the key, here mix column, here inverse mix column, here shift rows, inverse shift rows, here byte substitution, inverse byte substitution, add round key, and round. So grouping the functions into round is somewhat different from encryption. Here the first round consists of 4 functions, second round consists of 1, but except the last round consists of only 3 functions. It does not have inverse mix column. So you can understand my illustrations. How the structure is identical from plaintext encryption and decryption. So the central portion is key generation process. So 128-bit key is used. This 124, that means 128-bit is divided into 4 words. W means word. 4 words means each word of 32 bits. So the add round key is used in this key. After the key is expanded, then every round the key is generated from this main key. So this is one is next key, then next key, next key. Now there is some arrows missing. Here this arrow is going to this direction. Hope you can understand the structure of AES encryption and decryption. So here see this diagram. It is shows each round. What happens inside each round? Actually, input is 128 bits. So the 128 bits is split into 16 bytes. So 16 bytes means 16 into 80, 120 bits. So 16 bytes means the ordering from A0 to A15. This diagram shows what happened inside each round. So each round we have 4 process byte substitution, 6 rows, 6 columns in a round key. So the input 128 bit is split into 16 bytes, starting from A0 to A15. Then it is grouped into 4 words. This is first word, this is second word. 4 words, each word has the size of 32 bits. So this is first word, second word, third word, and fourth word. So the first word is given to some process called the byte substitution. In this regard, we use substitution process. So we call it S boxes. So there are 16 S boxes, but in the AES algorithm we use only 8 S boxes. I hope remember. So in the AES algorithm there are 16 S boxes. So S boxes are used to perform byte substitution. The output of S boxes becomes B0 to this thing. After that, it goes to the process of shift rows. Shift rows means the position of the bits are position of the bytes are changed. So for example, B0 is moved to this position, B3 is moved to this position, B15 is moved to this, like that we get the value. So that is called as shift rows. After that, we do some process called mix columns inside each word. Then it goes to the process of add round key. So each byte is given to some XOR operation. Then the R0, R1, R2 denotes a key. Because key size is 120 bits, it is also divided into 16 bytes. So each byte is given to an appropriate input bytes. We get so the plus denotes the XOR operation. We get some output. If the output is the input of the next round. So hope you can understand what happens inside each round. So each round has 4 functions. One is byte substitution, second one is shift rows, third one is mix column, and the last one is add round key. So byte substitution will be done with the help of the 16 S boxes. Shift rows, changing the position of the bytes. Then we do the process of mix column. How do you perform mix column? We will see in the detail later. Then we do some process called add round key. So 16 bytes are XOR with the appropriate 16 bytes of input key. So R0, R1, R2 up to R15, which represents the 16 bytes of the input key, because the key size we use here is 128 bits. Hope you can understand the insert process of each round.